Okay, welcome Roxy and Marquette and Jack and Marina and Liz and Jose and Jacqueline. Thanks for coming in, and let's jump into that quiz. Okay, so here's the quiz. And it says, suppose students spend on average, oops, it should just say on average, not on average twice, on average, 150 minutes studying for their exam, and that the standard deviation is 35 minutes. For each, A, write down the distribution. B, answer the question. C, determine if the assumption that the distribution of the population is normal was necessary for your calculations. So the first one is, if 6 randomly selected students are surveyed, what is the probability that their average time to study for their exams will be between 120 and 160? Okay, so for each of these, we have 3 things to do. So notice there's a total of 6 things to do, A, B, C for number 1, and A, B, C for number 2. So let's take a look at this. Well, we know the mean is 150, the standard deviation is 35, but we're looking at an average of 6 students. So what big theorem can we use? What's the big theorem that we're going to use? It's the theorem for the whole class. I don't see y'all jumping in. So maybe you can't hear me, or say I don't know, or tell me the theorem. There we go. Yeah, the central limit theorem. So we're going to use a central limit theorem. And the central limit theorem says that the average, and I'll kind of do it the way you would probably do it instead of really fancy math. So let me write 1A, because we're doing part A. The average is X bar. X with a bar on top. Bar on top is actually kind of a pain with Canvas, so X bar works. Okay, you just have to, communication is the most important thing. Okay, and the idea is that we're assuming normality, and see if we need to assume it. And what is the mean of the average, given the information we've got here? Looking for a number. Number or formula. What is the mean of the average? Yeah, 150. So the central limit theorem says that the mean of all possible averages of that sample size is just the population mean. So that mean of the average will be 150. So 150, remember writing down the definition, the distribution means, or not X bar, it's tilde, sorry about that. So it's X bar tilde and 150. Now, what is the standard deviation of the averages? Or how do we find it? So what's the standard deviation of the averages? There's a big formula, that's a hint. Yeah, it's 35 over the square root of 6, because it's always sigma over root n. Sigma is 35 here, because it's been told to you, and n is 6. So 35 over the square root of 6. Okay, and there's our part A. That's our distribution. We've now written down the distribution. Part B, it says, answer the question. And the question is, what is the probability their average time to study for their exams will be between 120 and 160? Okay, so we want the probability. 120 less than x bar less than 160. How do I find a probability when we're given x bar tilde n 150 35 over root 6? What do we have to do? You're all being kind of quiet, but hopefully you should all answer. So how do you find this probability? What do I do? Yeah, normal probability calculator. And I do want to let you know that is an absolute requirement, is to know what calculator. It's not something I'll ever tell you during a quiz or an exam. It's a big part of this class. And note, on the final exam, you're going to have 25 different calculators you have to keep track of. So you do want to practice, and the quiz is the best practice for it, which is why I don't give it away, because I want you to learn about it. And if you don't get it on the quiz, you don't lose a lot of points, but maybe you'll remember it for the exam, because the exam is a lot of points. Okay, so we want a normal probability calculator. Any questions on that? And just note, the low will be what? $120. The high will be what? The key is we've kind of written everything out. 160. The mean will be what? And again, it's all there for us. So what's the mean? 150, because that's what this number here, 150 is. That's the mean. And the standard deviation is 35. It's not 35, it's 35 over the square root of 6. Okay, and to do that, I need my scientific calculator. So it's all embedded in here. So you go 35 divided by, we need a square root of 6. And it's 14 point, a lot of numbers. I'm just going to copy and paste. And there's our standard deviation. And I hit calculate. And there's our probability is 0.74 about. Okay. And by the way, if you want to show your reasoning, you can always write this down. Low is equal to 120. High is equal to 160. The mean is equal to 150. And the standard deviation was, what was that number? 14.3 or so. Any questions on part B? Okay, let's do part C. Part C is determine if the assumption that the distribution of the population is normal was necessary for the calculations. How do you decide whether you needed to assume the distribution was normal? Who remembers what the central limit theorem says about that? When do you not need the population distribution to be normal? That's another way of saying it. So who remembers? Yeah, for a large value of n. And what was our class's definition of large? Yeah, over 30. So what do you think? Do we know it's normal, or do we have to assume it's normal? Yeah, we must assume n is 6, so let's write this out. So for part C is n equals 6, which is less than 31. Remember, bigger than 30, less than 31. Those are the two pieces. So we must assume the distribution of the population is normal. Any questions on number 1? Okay, let's look at number 2. So for number 2, now the question, let's go back and read it, is there's a 23% chance that 34 randomly selected students will on average at least how long studying for their exam? Sorry if the grammar's not perfect. I was probably tired when I wrote this, but will at least study for at least how long? Okay, so what changes for part A? Not much compared to the last part A. So I'm going to copy and paste the last part A, and there's not much that changes. What changes for part A now? Yeah, the standard deviation, in particular, this 6. So the 6 was part A, and we're changing from part A to part B. And for part B, we don't have 6 randomly selected students. Now we have 34. So that means this 6 becomes 34. Any questions on part A? Let's do part B. Okay, so part B now. Now we want, there's a 23% chance that 34 randomly selected students will on average at least how long? Okay, at least. Are those, that means big numbers or small numbers? So at least are big numbers or small numbers? Is it a left side or a right side? Not at least. If you're at least 21 years old, are you a child or are you an adult? Or if you want to go 18, if you're at least 18 years old, are you a child or an adult? One way of looking at it. So at least means more than. Okay, that much or more. Not smaller than, but more than. Any questions on that? Okay, so that's really important, is that we're looking at the right-hand side, not the left-hand side, because at least are the larger ones, okay, or the longer ones in number of minutes. Okay, 23% chance. So now we have this calculator again. What's the low this time? What can you tell me? What do I put in for low? Because here's a hint, it's not 120. What do y'all think? So what's the low? Okay, I don't see y'all jumping in. So if we want to find out how long they're studying for the exam, if they're at least some amount, the low is what we don't know. So that's the one I leave blank. So it's not negative 9999, because negative 999 is not at least something. That's the left side. We want the right side. So low is empty. And what's the high? The hint is the high we do kind of know. The low is what we want. How do we decide on what the high might be?
Wouldn't it just be like 9999?
Yep. So it's going to be a bunch of nines. Okay. What's the mean? Does the mean change? That's a hint. Or is it still 150, or does it change? So here's something to look at. Let's look what we've already done. Does the mean change, or is it still 150?
It'd still be 150, but why is the standard deviation weird?
Okay, let me do 150 first, and then we'll get to the standard deviation. So one thing at a time. So the mean stays the same. And now the standard deviation, question is, what is the standard deviation? And that's this. So how did I get, I guess I need one more parenthesis, but that's probably not your question. How did I get 35 over the square root of 34?
Yeah, essentially.
Okay, so the central limit theorem, let me just write this out. CLT states that sigma sub x bar is equal to sigma over the square root of n. Okay, that's kind of in wordy symbol stuff.
Can I get that in? How do I put this in human speak, please?
If you want to find the standard deviation of the sampling distribution, and that sampling distribution is something you need to learn. You need to know what those words mean. If you want to find the standard deviation of the sampling distribution, you take the standard deviation of the population and you divide by the square root of the sample size. That's in words. Still math. It's always going to be math, but that's how you can say it in words if you want.
I'm sorry, but can you please repeat that? I'm trying to write it down.
Okay, maybe I'll type it. How's that? So
that would be excellent. Thank you.
Yeah, and this happened last week. Standard deviation of the sampling distribution for means is the standard deviation of the population divided by the square root of the sample size. So that's in kind of lots of words if you like words.
Oh, yes, I do. I'm an English major.
But you have to understand how to use it, not just how to say it. So you have to know that.
Well, the first step to understanding how to use it is actually understanding the concept.
Absolutely. But practice. Yeah. So again, the standard deviation of the population was 35. Sample size was 34. So it's 35 over the square root of 34. Okay, which we're going to have to use our calculator for. So let's change that 6 to a 34. And the nice thing is, there it is.
Wait a minute, so is this the same calculator we used for the chapter on normal distribution, chapter 6?
Same calculator, yeah.
Okay, excellent.
Yeah. Because the central limit theorem says, that's the whole point of the central limit theorem. It says that when you're looking at a sampling distribution, you can do chapter 6. Do you see? But you have to use that formula. So there's our standard deviation. We want a 23% chance. So that means our P is 0.23. And I hit calculate, and there we go. So 154.43, I'll go a couple decimal places. So part B was 154.43. How about part C? So let me remind you of part C. Determine if the assumption that the population was normal population is normal was necessary for your calculations. So how do we decide on that one now? So do we need to assume that the population was normal? Maybe I'll pop in there. So what do you think? What's the key thing here? Do we need to assume normality? What do y'all think? Or do we not need to assume normality? So if you read the question, there's a key number here. There's not a lot of numbers here that will help you decide whether you have to assume normality.
Assume normality.
Okay, and how come? Okay.
Oh, wait, never mind.
I like Marquette's answer better. N is 34. Yeah, so N is 34. Which is greater than 30, unlike 6, which was less than 31. So the central limit theorem guarantees that the distribution, the sampling distribution, is normal. So we don't need to assume that the distribution of the population is normal. Any questions? Any questions on part C? Any questions on the quiz? Okay, if there's no questions, let me go back to kind of what we're doing today. I want to just kind of read through what we did last time as a refresher. I'm just going to scroll through what we already did. Okay, we already saw that if you're talking about quantitative data, that you have a mu, an x bar, a sigma, an x. Those are all different symbols. And it's important that you understand what the symbols represent. Mu is a population mean. X bar was a sample mean. Sigma was a population standard deviation. And S was a sample standard deviation. So it's just a quick review of what happened on Thursday. Okay, stop me if you have any questions. But again, all I'm doing is rereading what we already did. Okay, we could talk about the sampling distribution, which if you look at all samples of the given sample size, in our example, we had a 3 sample size, then the sampling distribution is a distribution of all means for those samples of size 3. And that anytime you have a list of things, in this case, a list of numbers, which are means, you could always take a mean and a standard deviation. So the big theorem was the central limit theorem, saying that the mean of all the possible sample means is the population mean, and the standard deviation of all the possible sample means is the population standard deviation divided by the square root of the sample size. So again, I'm just repeating what happened on Thursday because we're gonna move on a bit. And furthermore, if the population distribution is normal, or if the sample size is larger than 30, and that's really the biggie, because in the real world, you just get a sample size larger than 30, even though it's a pain because it takes a long time, you deal with it. And then you can use the normal distribution. Okay, doesn't necessarily mean you're going to get great data, but at least you can use the normal distribution. We'll talk later in a few weeks about other reasons why you might want a larger sample than this. But for now, at least we can use the normal distribution and compute probabilities. If you have a large enough sample and you're looking at a probability of an average being greater than something, less than something, or between something. Any questions on the central limit theorem? Any questions? Okay. So we looked at an example and we realized that if there's a big difference if you're looking at an individual versus a sample, and the probabilities are very different, whether you buy one stock in the example I gave last time, or whether you purchase a collection of stocks and look at the average of all of those. Okay. Okay. And by the way, just for fun, I'll tell you, I did this today. I actually bought a stock today. I already made a couple $1,000s on it. It was a good day. So if you see me smile, you understand. Because I planned it right. I timed it perfectly, almost within 10 minutes. But so use math and you can make some money, eventually. Could also lose money. Okay, so now comes the next theorem, and that is the proportions. Okay. Wait, so I missed something. Can you tell us which one? I wonder if I missed that in the chat. I see. Can you tell us which one? What are you referring to again? Sorry. Oh, which stock? Is that what you mean? Yeah, I bought Airbnb. I'll let you know that. And we'll see. I made money today. I haven't sold it yet, but it did very well today, from when I bought it to when it closed. So it was a good day. And again, I use statistics. It really makes a difference. Okay, I can't get into the details. It's too complicated, but I will tell you that statistics helps. Okay, so now comes the central limit theorem for proportions. So now we're moving on and going to the next big central limit theorem. So again, last time we talked about all about means. And I do want to remind you, I mentioned this on Thursday, that chapter 7 is on exam 2, but not on exam 1. So you'll not be tested on this on Thursday. In 2 days, you take a test. If you use the central limit theorem on Thursday, what does that mean? Any guess?
You're doing it wrong.
Exactly. You screwed up. Okay, don't even think about using the central limit theorem on Thursday. Okay, on the other hand, 3 or 4 weeks from now, when you have the next exam, if you don't use the central limit theorem, that means you screwed up, on the next exam that's happening, I think, late May. But for this exam that's in 2 days, the chapter 7 is not on the exam because I don't believe in testing you on material that you haven't had the homework on yet. And the homework's not due till Sunday, and you're tested on Thursday, so I don't think that'd be fair. Whether you agree or not, that's my rule. If you wanted it on the exam, then sorry, but it's not going to be on the first exam. But that doesn't mean it's not important. So you need to take care and listen. And in fact, we're going to spend a lot of time talking about the exam in the last hour or so of class, maybe 45 minutes. So we will do that. But I want to do now the central limit theorem for proportions. So when we had a central limit theorem for means, a survey question was quantitative. So the quiz example, the survey question was, how many minutes do you study for an exam? Okay, that was a survey question. And an answer to that would be something, I study 195 minutes. Okay. And that would be an answer. Okay. By the way, any guess on when I was a college student, when I had, a big math test coming, any guess on how many minutes I studied and practiced? Six hours, usually about 8 or 9 hours. My motto was that if I walked outside and saw daylight, I didn't study enough. So I just made sure the day before the test, I studied the whole time and practiced. And as you might guess, if you practice for 8 hours, you do pretty well. So that
seems unrealistic for a lot of us.
Well, you do what you have to do, That's I'm just telling you. I'm not saying you have to, but I got 100% on most of my tests. And it matters. If you can, go for it. I don't say you have to study 8 hours or 9 hours, but it's, it definitely helps. And when I say study, I mean practice. Some of it was social practicing. So I didn't do it alone. I always had a friend to work with, and, we worked together, a little harder online, but it can be done. Okay, so that's just a note. So quantitative is a central limit theorem for means. Now we're going to deal with the yes/no survey question. And very important to know that when you're talking proportions, the first thing is the letter we use for the population proportion is P. Okay, and that shouldn't be a big surprise. It's the first letter of the word proportion. Okay, and the letter we use for the sample proportion is P. And notice there's a little hat on top of the P. The formal way, the mathematical way of reading what I'm looking at is P hat. So mathematicians could be easy sometimes. So you just read it as P H-A-T, P hat. So just let you know, you're not going to be, it's really hard to type this thing to get P hat typed, especially in Canvas. So P H-A-T is just fine. I don't grade on whether you have, perfect font and format. What I want is good communication is what I want.
Okay. Will we be quizzed on this on Thursday?
No, that's what I just said, is that it's not on the exam.
No, I asked if we'd be quizzed on it, not if it was on the exam.
On Thursday? No, not on Thursday, but yes, a week from today.
Okay, excellent. Thank you.
Yeah. No. The exam, I'll tell you, those 2 hours, the 2 hours and 50 minutes or whatever, all you do is take the exam. That's it. There's no lecture, there's no Zoom, just exam. Okay, so you have the entire time. That's all you focus on. Okay, some of you will finish earlier and you're done. And some of you need the whole time, but it depends on your style. But you will get quizzed on this a week from today. So this is important. Okay. So we use this p hat for the sample proportion. I do want to let you know that 25 years ago, when I first started teaching stats, might have been 26 years ago, actually, we had different letters. We used like mean, use mu for mean, because that's the Greek letter for M. Do you know why it changed? I didn't, but the world changed and I was happy about it. Do you know the Greek letter for P? And my hint is you all do. It's possibly the first Greek letter you ever learn in your life. Yeah, it's pi. And pi just confused the heck out of everyone because everyone thought 3.14, and so that I definitely noticed that 20 years ago or so, they made the change, statisticians. And I just go with the flow. So whatever everyone in the world's doing, I try and do the same thing. So we use P and P hat now. If you read a very old textbook, you'll see it differently. Okay, then Q is 1 minus P. So remember, P is the proportion of people, if it's a person sample, it's the proportion of people who said yes to the survey question. What is Q? Any guesses?
Portion of people who said no.
Exactly. Right? If you had, say, 70% say yes, and you want to find out how many said no, you take 1 minus 0.7 and gives you 0.3, 30%. Do you see how that works?
So is this just used for those kinds of qualitative surveys that are yes/no answers, or
Absolutely.
can it also be used for but can it also be used for quantitative data?
No, this is yes/no.
Always?
Yep. Now there's sometimes you take quantitative data and you turn it into a yes/no question. But no, this is for yes/no. For quantitative, we use mu and x bar. Does that make sense?
I'm just making sure that this is something that you're not going to say like next class, oh, but this is the really weird exception to it.
No. No. Yeah, the only time you'll hear something that sounds quantitative that's at P and a Q would be something like if the question was, do you get more than 8 hours of sleep a night? It kind of sounds quantitative, but it's really a yes/no question. Because you could change that question, say, how much do you sleep? And then it wouldn't be a P and Q. But if it was, do you get more than 8, then it's a P and Q. Any questions on that? This is definitely yes/no. Absolutely yes/no. And here's the punchline. Let me scroll a bit so I can put it all on the same page. Okay, so the punchline is the following. Is the sampling distribution for sample proportions. So remember that if you conduct a survey of, let's say, 1,000 people, then everyone hopefully will answer your question, yes or no, and you could look at the proportion of people who said yes. And that might be, 0.62. And then if you do another survey of 1,000 people, then you can look at the proportion of people who said yes. And that might be 0.45 the next time. And then you could do another one and see how many people said yes. And that might be 0.55. And you could do 1,000-person surveys all your life. And you could list all those proportions. Now notice the proportions themselves are numbers, right? Because if you ask 1,000 people and 55% said yes, then that proportion is 0.55. So if you list the proportion of every sample, you're listing a bunch of numbers. And when you have a list of a bunch of numbers, you could talk about its sampling distribution. In other words, you can think about the mean of those numbers, the standard deviation of those numbers, and the shape of the histogram when you plot those numbers. Any questions on that idea? Okay, so if you look at all of the possible sample proportions of sample size n, okay, those proportions will all be p hats. Might be, one p hat will be different than the next p hat, different than the next p hat. But if you take the mean of all the p hats, then That's a mean. So it's a mu sub p hat. And the central limit theorem says that mu sub p hat is equal to the population proportion. So that's very easy. Any questions? The hardest part is reading the symbols and understanding what they mean.
What that first one means is essentially that the mean of the sample proportion equals the population proportion.
Let me add a few words into what you said. The mean of all possible sample proportions is not the mean of the population proportion, is the population proportion. There only is one population proportion, right? If you want to find out the proportion of Americans who, I don't know, who worked at home during the pandemic, there is a proportion of all Americans. There aren't many of them. But if you took a sample of 1,000 of them, you're going to get a proportion. And if you ask 1,000 different Americans, you get a different proportion. And then if you went and asked a different 1,000, you'll get a different one. So mu sub p hat is the mean of all the sample proportions. P is the population proportion. Does that make sense?
Somehow you made it more confusing.
Okay, there was only one population proportion, period. But there's many sample proportions. So if you remember on Thursday, we did that little experiment where each of you picked 3 and found your sample mean. And there were a lot of different sample means. Well, same idea. I could have had each of you, do a survey of 100 people, and you'd each get a different proportion. And the mean of all possible proportions is the population proportion. The mean of all possible sample proportions is the population proportion. Okay. And again, if you have a list of sample proportions, you could talk about the standard deviation of all those sample proportions. And this one's a lot more messier. It's the square root of p times q divided by n. Okay. Remember, p is the proportion of yeses. Q is a proportion of no's. You multiply those and then divide by your sample size. Take a square root, and that gives you your standard error for sample proportions. I know it's a lot of language, but hopefully you get used to it. It's all in the book too. Okay. Just note, if n gets really large, what happens to this sigma sub p hat if n is really big? So if n is big, what happens? Yeah, there's less error, less standard deviation of all the possible p hats. And then there's what's called a smaller standard error. And what that means is that if you conduct a study and get a sample proportion, then it's much more likely that your sample proportion will be closer to the population proportion. And that's what you want when you do a sample. You want your sample to predict the population well. And if you have a large sample size, then this always works. Okay. This assumes no bias. Bias messes everything up. You can never do anything with bias, by the way. Okay. No, there are no theorems that say, if you have bias, then this is a new formula. It's just bias is bad. Any questions all on the central limit theorem here? Okay, number 2. This is a biggie, and it's a big problem that a lot of people have. And that is for proportions. The number of 30 is not part of the central limit theorem. It doesn't happen. For means, the number 30 was the key borderline in being large enough or not large enough to have a normal distribution. Here, it doesn't work that way. Here, it's if NP, okay, and by the way, NP is the predicted number of yes answers. So, and the way I like to look at it is, let's suppose that 80% of the population is going to say yes. And you ask 500 people, and you want to predict how many will say yes, well, you take 500 times 0.8. And that's your prediction on how many say yes. 80% of your 500 will be your prediction of yeses. Okay, and NQ, which is the predicted number of no's, by the way, because Q's are the proportion of no's, they need to be both larger than 5. Okay, not 30, 5.
And this only works for binomial distributions, right?
For the, yeah, basically, for the yes-no question. Yeah.
Yeah,
for
basically,
binomial.
or yeah.
Yeah, it is, but I didn't want to get into that word. Because there's some more complications. I don't want to even go there in this class. So yeah, it only works with the yes-no question. Just go yes-no. It's better. Okay. And then if you have that, then the sampling distribution is approximately normal. And just a big note, if you don't have they're both greater than 5, then you have meaningless data. Okay. It means that your sample size is just too small. Don't even do anything. Okay, there is no, but maybe the population was normal to start with. There is no normal with yes, no's. So you have to have MP and NQ greater than 5 to do anything we're going to do in this class when we have the yes, no question. Any questions on this idea, this big theorem? Okay, so I think it's time to use it. And one of the things I like, my favorite thing about teaching this class is I don't have to ever convince you why you would ever need this stuff, because it's so easy to just go online, find a news article, and say, yeah, if you don't get statistics, then you really don't understand what's going on. And so it was this was really easy for me to find an example. Like for the means, I was able to just go into the stock market. Here, let me give you a poll, an article. And I just like CNN if I can. I mean, it's easy to get online and look at CNN. It's free. Doesn't ask you for any IDs or anything. There's advertisements. I can handle that though. Okay. And what it says is most satisfied with the, I can never pronounce it, Chauvin verdict, but partisans divide. That's the name of this article. Huh? Chauvin?
Chauvin.
Okay. Yeah. As you might guess, I don't even have television, so I never actually hear them say anything. All I get to do is read it. Okay. So pronunciation is really hard for me on people's names. Okay. So I'm not going to read the whole article, but I'm going to read a piece of it. I'm going to read a few pieces. Let me read this first sentence where they actually talk about some numbers. And that is expectations for changes to the way Black people and other racial and ethnic minorities are treated in American society following the verdict are mixed. Okay, and I'm just going to focus on the 53% say they're likely. Let me ask you something. Do the majority of Americans think that, expect it to be likely that there'll be changes? What do you think? So do the majority of Americans think that it's going to be likely that there'll be changes? Any thoughts? So do you think we have, huh?
No.
Why not?
Well, I know that you just highlighted the 53% say it's likely, but then it also says, and most 55% say their view of the nation's criminal justice system is unchanged by the verdict.
That's a whole different thing. Right? This is about treated, not criminal justice system. Okay, there is an issue, but it's not the issue you brought up. The issue you should worry about is, do they know about all Americans? Did they ask every American? Yeah, how do I know personally they didn't ask every American? I can tell you with 100% certainty, yeah, they didn't ask me. Okay, did any of you guys get asked? I've never had anyone get asked on one of these surveys. Yeah, yeah, they probably didn't. So let's scroll down a bit, because they actually give us the information, which was nice. This is a CNN poll. I mean, this is, a CNN article. It's not some fancy statistics thing. And down, let me find it again. There it is. It's usually at the bottom because most people don't care, but we care. They had a sample of 1,004 adults. So they asked 1,004 adults. So what we can say is, well, maybe it wasn't the majority. What's the biggest percent where it's not the majority? By definition. What's the largest percent to not be the majority? Based on the word majority. Not 49, because 49.5 is still not the majority. Turns out 50% is not the majority. So the majority means more than 50%. So yeah, not the majority. So 50% is not the majority. So the largest percent to not be the majority is 50%. Does that make sense? 51 is the majority, so is 50.5 the majority. And that's less than 51. So 50 is that borderline, the exact borderline. We got, 350 million people in this country. So you could definitely get really close to 50% on either side and be the majority or not be the majority. So just let you know that. So we're going to use 50% as that borderline because that's the definition of being a majority. Any questions on that? Over 50% is the majority, 50 or under is not. So now let me go back and let me state a question. So the question is, if 50% of Americans don't think it is likely, okay, and I'm not going to write it all, but don't think it is likely that America is going to change in the way it treats Blacks and other minorities, but I'll say it instead of type it all. It's a lot of typing. Okay. Then if we survey 1,004, oops, wrong one, that one, randomly selected adults in America, what would the probability be of getting at least 53%? Because that's what the survey found, saying it is likely. So I want to let you know this is the biggie. Okay, we're going to spend chapters on analyzing this kind of probability. Is saying that if you do have some set number and you did the survey with that sample size, what would the probability be of getting at least what you got, or maybe less than what you got, or different, it turns out. At least is extreme, but I'll let you know that's happening in a couple weeks. I'm going to spend a lot of time on that. So right now, I just want to write it out, get you ready for it. Any questions on the question? Okay, so now let's put everything together. First thing, what is P? What is P in this case? And the hint is it's not hard. It's written in there, written in that sentence. There aren't a lot of choices. Turns out it's not 0.53. My guess is it would be your second guess. So what's P? Take a look, read it. There aren't a lot of choices. It's not 0.53. There's only two other numbers hidden in there in this sentence. Yeah, 0.5. Because that's the proportion that we're saying of Americans, of the entire population, that don't think it is likely. Okay. Okay. Or think, maybe I should say think it is likely. Don't. Either way, it doesn't matter you say don't think or think because it's 50%. But I think I'm going to write think. What is Q? The hint is that's really easy. We had a formula for Q. Here's the formula over here. So tell me what Q is. What's Q? Looking for a number. Right? If 50% think it's likely, remember Q is the ones that say no. 50% say yes. Yeah, it turns out for this example, 50% also say no. Now, that's not always going to be true. It won't always be the same. Only it's a special case of 50%.
Will Q be given to you? Never mind.
No, if P is given, you know Q.
I answered my own question in my head. Never mind.
Okay, yeah. Q is 1 minus P. Always. And it's very simple to do 1 minus a fraction. Okay, or a decimal. Okay. Calculator is always given to you, though. Now, what is N? That's easy. So what's N? Yeah, 1004, because that's the sample size. Okay, let's see if we have a normal distribution. Let's see if we can even do this. So to see that, we need to check NP. So N times P is 1004 times 0.5, which is 502. And we also need to look at NQ. Maybe I'll write out what I just did, actually. NP is 1004 times 0.5, and that was 502. NQ turns out to be the same because P and Q are the same, but it won't always be, just let you know. 1004 times 0.5, and that's also 502. Why do I care? What do I do with those numbers 502 and 502?
Because they're more than 5, and we can assume that it's normal.
Since both are greater than 5, we can use the normal distribution to approximate the sampling distribution. Any questions on that? Okay, well, that tells us now with the central limit theorem is that p hat tilde, whoops, n. So in other words, the p hat is normally distributed with mean p, which is 0.5, and standard deviation, the square root of the fraction PQ, 0.5 times 0.5, divided by n, which is 1,004. Any questions on writing the distribution? So if I ask you, what is the distribution? The sampling distribution, that's the sampling distribution. Any questions on this?
Just to make sure I get it.
Mm-hmm.
So it's n and then parentheses, technically p square. And why is it a comma? What do you do there?
Well, because you have two numbers. You have the
there?
mean and the standard deviation.
Okay.
And you separate two numbers by a comma. That's why.
So then how do you solve that?
Okay, so the next thing I do, and I'm not sure if this is what you mean by solve, is I pop this guy into a calculator, the square root of 0.5 over 1,004.
Okay.
And in fact, I'll show you how to do it using this way. So we want normal probability because we had an n. N means normal probability, right? I can do scientific calculator. And I could do a square root. And then I could do 0.5 times 0.5 divided by 1,004. And I get this number. Take a bunch of decimals. So I'm going to write equals n 0.5, comma, those bunch of decimal numbers. Any questions on that? Is that what you meant on how do you solve it?
I guess, like, where do you go with that value?
Oh, okay. What do we do with it? Not how do you solve it, but what do we do with it? Okay, so remember what the question is. I'm not there yet. Right now, I just found out what the distribution is. But then is what would the probability be of getting 53%? So what that means, so our question is the following. Find the probability that p hat is greater than 0.53. Okay, so that's what we're interested in. I'll make this bigger so you can see it better. That's what we want. Any questions on that?
How does the distribution help you find that?
That's what I was about to say. N is really important. What does that tell us we need to do? When you see an N, capital N, what does N stand for? What word does the N stand for? Very important. Yeah, normal distribution. So we use the normal probability calculator. So that's why I actually went to the normal probability calculator so I could just be there. We know the mean was 0.5. The standard deviation is this messy number. Okay, and we want the probability that we're greater than 0.53. So the low is 0.53. And greater than You could either go 9999. I'm going to do that because technically with the normal distribution, that's what you got. Okay. Even though probabilities can't be more than 100%, but we are assuming it's, it's approximately normal. And either way, you'll get the same answer, it turns out. Any
Okay,
questions
so
on that?
wait, the distribution helps you find the standard deviation?
So the distribution gave us a standard deviation. It gave us a mean. It gave us to use the normal probability calculator. It gave us all of that.
How does it give us the mean?
There it is, right here.
Wait, how is that the
Okay. There's the central limit theorem, mu. Mu equals P. So that's the big theorem. Okay. By the way, the proof of the theorem is way, way beyond this class. It's graduate level, so that's not going to happen. But you got to trust the theorem and understand the symbols. So mu equals P. Sigma equals the square root of PQ over N. So there's our mean and standard deviation for the sampling distribution. Is that clear? So it's there for us, mu equals P. So that's how it gives it. Okay. And, oh, what I didn't do is hit calculate. There we go. 0.0286 or ish. That's close enough for anyone that would care. So the answer is that. And there's our probability. Any questions on that? So if you want to find a probability, and we're looking at the yes/no question with many people asking, and you want to find the probability that the proportion will be bigger than a certain amount, then this is how we do it. Any questions on this? Okay, it's 5:02 right now. I'd like to give you a 5-minute break so that we can get back and talk about the test and stuff. So we'll come back at 5:07, and then we'll do the last bit and then the test, talking about the test.
Hey, Jose, do you mean on the calculators that you'll be using for the exams?
No, like he had it set up to do the square root for, I guess, P. He had 0.5 and 0.5 over 1004.
Oh yeah, for sure. Uh, hopefully it lets me share my screen. Yeah, I think it does. Okay, can you see the calculators?
Yeah.
So it's just that square root, and then if you're gonna have a division, you can put AB. 0.5 times 0.5 and 1004.
Oh, okay.
It's just using this and this mainly.
Okay. Thank you.
Was that your question?
Yeah.
Yeah. For the
Okay.
fraction, you can also use the slash, by the way. Just type the slash.
Oh, so okay, yeah.
That's how I used to do it.
Thanks.
Oh, sweet.
Okay, I see 5:07 on my clock, so it's been the 5-minute break. So let's get back because we still have something really important, but we got one small thing first and then an important thing. So the last bit of the central limit theorem is sometimes you care more about sums than you do means. Can you think of a situation where the sum is more important than the average or the mean? The sum is a total. Can anyone think of a situation where you care more about the total than the average? In the situation in the real world. And there are a lot. Can anyone think about where you care more about the total than the average? So can you think of a situation where the total is more important than the average? Don't see you all jumping in, but it's not a trick question or anything. All right, I don't see you all jumping in. All right, maybe I'll give you an example then. Okay, imagine you own a store. Okay, I'll make it Tahoe. Let's suppose you have a bike rental shop. Okay, or a bike shop where you sell bike and supplies and all kinds of stuff. Okay, since by the way, I just biked around the lake on Sunday, so it's in my mind right now. So you're a manager, you're owner of that store. Then can you imagine what you care more about? The average amount of money people spend or the total amount of money that gets spent in a day? If you're the owner of the store, what do you think is more important to you? We got a quiet group today. Can you hear me? Make sure I don't have my mic. Well, it looks like I'm talking yet. Can you hear me? So if you own a store, like a bike shop, do you care more about the total amount of money that's spent in the end of the day? Or do you care about the average amount of money that people spend if you're the owner of the store?
At the end of the day.
Yeah, it's the total that you care about. So how much money you make by the end of the day, that's all that matters. You don't care the average number of dollars people spend that much. And it's kind of nice to know, but it's not the big thing. The big thing is how much money gets into your cash register. That's what you care about. Okay, so that's one example, kind of the biggest example where total or sum is more important than average. Any questions on that? Okay, and I want to mention, I think I'm going to scroll up. I have it showing, but I'm giving you the punchline, but let's see where it's all coming from. And I'm going to scroll from the very beginning, what we did on Thursday, and that was right here. If you know the average, how do you get the total? Let's say I surveyed 100 people and they averaged, $50 they spent at the store. Then how do I get the total? If there are 100 customers and they average $50 each, what do I do? You guys with it? So if the average was $50 a person and there are 100 people, how do you get the total? Yeah, you multiply the two. Okay, you take the average times the sample size, and that gives you the sum or the total. So if I take the central limit theorem and I multiply these by the sample size, then I'll get an n times, or a mu times n, or an n times mu, and I get a sigma over root n times n. Okay, now you may or may not remember your simplification of roots in the denominator, but it turns out if you have over root n times n, that just becomes times root n. And that's where the central limit theorem for sums is coming from. And that's all that happens. Okay, there's no fancy anything. That's the entire proof, basically. So now let's go back, or go down, to the big central limit theorem for sums. Okay, and it says the following: the sampling distribution for sample sums for samples of size n has the mean of, it shouldn't be x bar actually. It shouldn't be mu anymore. It should be the mean of, not x bar. But does anyone know the symbol for sums? For a sum?
Yeah, it's the weird backwards looking Z thing.
Yeah, this
That
guy.
one.
Okay. And you may not know it, but this is actually one that's already there, but it's a capital. Remember, this is a Greek alphabet. And they have, just like English, they have capital and lowercase. Turns out this standard deviation is lowercase sigma, and this sum is uppercase sigma. I don't know if you ever knew that, but that's what it is. Okay. I rarely have anyone, in fact, I never had anyone that's fluent, that where their first language was Greek. But if it was, then you know this. This just comes from Greek. Okay, so mu sub sigma equals n mu, and sigma sub capital sigma equals sigma root n. And it turns out the normality is exactly the same as normality for just for means. And that is if the population distribution is normal, or if the sample size is large, larger than 30, then the sampling distribution for the sum is also normal. Any questions on the central limit theorem for sums? Okay, so here's an example. Let me type one out, make it a little bigger. Okay, suppose that a bike shop averages, bike shops customers average $85 each. Right? Some buy a bicycle, some rent a bicycle, some just buy a patch, who knows? Okay, and their standard deviation is $60. If 40 customers come in that day, find the probability. Actually, let's do this. Find the, because I haven't done one like this before or yet, find the third quartile for total amount of money spent. It wants the. Any questions on the question? Okay, then the first thing we're going to do is we're going to write down the sampling distribution using the central limit theorem for sums. Okay, so to do that, the first thing we have to note is 40 is a sample size. That's bigger than 30. Why do I care?
Because
Yeah.
you can assume it's normal.
Yeah, we can not assume. Remember, assume, the first three letters of assume. Don't forget what those are. We never want to have to assume. So we can conclude that the sampling distribution for sums distribution for sums is approximately normal. Otherwise, we can't even do this problem. Any questions on that? Okay, so now what I can do is write down the distribution. Now the distribution, first thing, the letter I'm going to use is this capital sigma, sum, and then tilde, and then n, because we know that it's normal because of the central limit theorem. And how do I get the mean for the distribution of sums? It's all there for us. What do I get? How do I do it? Yeah, we take the sample size, which is 40, times the mu, which was 85. And similarly, I take the standard deviation for sums. I take the standard deviation, which was 60, and then times the square root of the sample size, which is 40. Any questions on that? Okay, and then you could do the calculation. Let's see, 340, I think is 3400, 3,500, I believe is the 40 times 85. Yeah. Okay, use a calculator. You don't have to do it in your head. I might be wrong. I did it in my head. 60 times root 40, that one I can't do in my head. So let's go to our calculator. We can go 60 and then times, and then I hit the root button and I go 40. And it gives me 379.4733-ish. Good enough for me. Any questions on that? Okay, we want the third quartile. So let's go to the normal distribution. So the mean was 3,400. The standard deviation was that messy number. Okay, what do I know and what do I not know if I want the third quartile? I got the mean and standard deviation. What about the low, high, and p? Which one's not known? Which ones are known? What can you tell me? If we want the third quartile. And remember, you're not going to be tested on the central limit theorem, but you are tested on chapter 6. I could ask you, what is the third quartile if you know the mean and standard deviation? And you need to be able to figure that out. So what do I plug into this calculator? And what do I leave blank? One thing gets left blank. Which one gets left blank? Okay, there we go. Yeah, the low is negative bunch of 9s. And the high is the one left blank because that's the third quartile. And then P is 0.75 by definition. That's what third quartile means. Then I hit calculate, and there's our third quartile, 3656 all around. So the third quartile is 3656. And this is dollar amount. Any questions at all on this example in using the central limit theorem for sums? Any questions? Okay, if there's no questions, then I want to get on to what I'm going to talk about, what we're going to do for the rest of the last half hour or so. And what is left to do today?
Review.
Yeah, review for the exam, talk about the exam. So let's go and talk about this exam because that is important. And let's see, I don't want that one. What I want, let me just pop in our class. And let me remind you, which I think I did change a couple things. I forgot to change it. Yeah, there's no if, so maybe I'll edit it now so you don't like worry about it. Because there's a couple little things that we know now that I didn't know for sure then. So it's not if, since. Since it can only be done online, and just like that. I was way over hopeful a month ago because I was hoping the vaccinations would convince everyone, but not until next quarter. Okay, so since it can only be done online, students you can bring pencil and paper. Okay, paper means blank paper. That's allowed. Okay, but I do want to let you know, let's see. Yeah, so for Proctorio, so there's a question for Proctorio. All we need to do is install the thing on Chrome, and that's it. Yeah, so that's all you have. Yeah, I mean, you have to take the test. You have to know statistics. So you install Proctorio on Chrome, click it, and then you'll be done. Okay, and I think it's in here somewhere. That was this one, practice with Proctorio remotely proctored. The hope was that you would have done it by last week and practiced. If not, maybe I'll change the due date for y'all so you can try some more. So let's change it from April 29th. How about till whoops, not the 27th, May 6th. I worry about putting 3:30 because this doesn't mean you should do it at 3:30, but this just means you can practice as many times as you want. So I created a practice Proctorio test. Okay, it's worth basically no points, 0.01. I can't make it 0, but 0.01 is basically 0. And hopefully that answers your question. So you should practice. You should take that practice Proctorio test and make sure it works. That's the most important thing. Does that make sense? Yeah, so I've set it so you can still practice. I had the deadline last Thursday, hoping everyone would do it by Thursday, but maybe not everyone did. Okay, and Chrome is a browser you should use. Okay. A couple things about Proctorio while we're talking about it. Sometimes, not always, I'd say about maybe 15% of the time, it says put in the access code. Let me tell you what that means. It means it's screwed up. So what you want to do, close it and reopen it. And then it shouldn't say put in the access code. There is no access code. But for some reason, Proctorio once in a while just gets angry. So sorry about that. Yeah, so there is no access code. So it means close and try again. And then then it should work. Okay, but make sure it works before you take this test. I've just set the practice Proctorio test to be later so that you can check it. Okay, and remember that especially if you're in Tahoe, you can go to the library, you can grab a computer. Those computers work with Proctorio. Okay, you have to have a webcam on your computer. That's one thing. I want to know about the webcam. How many people get to see this video that is going to have you in it? Any guesses? Yeah, only one is allowed, and that's me. How many people will probably end up seeing it? 0. Okay, what I do, let me tell you personally, is I grade your test, and if it looks fishy, like if you're using vocabulary that had nothing to do with what we talked about, but it's very high level statistics, that means you probably paid someone. Then I'll go watch the video and make sure that you're doing it by yourself. Got it? So if it looks fishy, then I just watch. But if it doesn't look fishy, I don't even bother looking. Okay. And if you don't cheat, then almost certainly I won't even bother looking at your video. So don't be worried about it. And also don't worry about cleaning up your house behind you, because I'm probably not even going to look. I mean, it can't hurt to clean your house, I guess, but don't stress about it. Again,
I realize this question is sus. I
What's that?
realize
Huh?
that this question is incredibly sus, but do we have to have our microphones on?
Yeah, you need to have your microphones on. And the reason is you're not allowed to
So
talk to other
crying is
people.
not permitted.
Huh? I'm probably not going to be watching your video anyway. I'm only going to watch it if you're obviously cheating. Got it? Okay. Most likely you're just talking to yourself and no one's ever going to see it. Got it? So don't stress about the microphone, because I probably won't even look in it and no one else can look. And if I happen to
This is
look,
what
the
a
only one that might look is my
constantly-
cat, and my cat doesn't care. Just let you know. So don't worry about it. Don't stress about that. Okay. Okay, so that's just a note. Another note is you get a 3x5 note card. This is important. You could put anything you want on that note card, front and back. Okay, so if there's a formula that you don't want to have to memorize, like a z-score, for example, or I don't know, or if there's a definition, put it on the note card. Put anything you want on it. You just show it that you've got your note card. Show your blank paper if you've brought blank paper, and then everyone's happy. So again, put on the note card whatever is going to help you. Got it? Any questions on the rules? Okay, in terms of the timing, by the way.
I have a question.
Yeah.
What if we by any chance need to go to the bathroom? Do we just what do we do in that circumstance?
Make it quick. Make it quick. Don't turn it off. If you turn it off, the whole thing falls apart.
Okay.
Okay. So try to go to the bathroom before. Better is to go to the bathroom before the test, right? Before the test. Like within 5 minutes before the test, go to the bathroom. That's your best bet.
Okay.
Okay. And I would have like water on your table with you, so you don't have to go and get water. You know what I mean? And have lunch beforehand. But if you want to bring food, you can bring food. That's okay. That kind of stuff is fine. Okay. Just a note. The exam. Aha. So that's exactly what I'm talking about right now. So I'm just showing it to you. The exam is due by 5:50, which is the end of class, and it starts at 3:30 at the beginning of class, period. Got it? It's more than 2 hours.
How many
3:30
questions is that?
3:30 to 5:50. So it's a
How
little
many
more than 2
questions
hours.
are on?
Huh?
How many questions are on the exam?
We'll get there next. We'll get there next. Okay, and that's kind of complicated, but I wanted to give you the timing first. So you get there at 3:30. You have till 5:50. If you finish early, you're done. But I do recommend if you finish early, make sure you check your work, make sure you answered all the questions. Don't leave anything blank. Okay. And then you can call it a day, because for a lot of you, it won't take the full, 2.5 hours. But if it does, it does. Okay, or 2 hours, 20 minutes, I guess. Okay, any questions on that? Okay, so now let's talk about the exam. So I'm going to give you, I know you wanted how many questions? I'm going to give you more information than you asked. And I'm going to talk about the questions, not just how many. So here's number 1. This is the question that you better get right. If you don't get number 1 right, I give you a 0 for the entire exam. So let me read it to you and you'll see what I mean. Write your name below if you agree to not communicate with any adult and not use any devices or materials for this exam that have not already been expressly allowed by your instructor. And all you have to do is write your name. Okay. If you're not willing to write your name, I give you a 0. You have to basically say that you're not going to cheat. Okay. Do you remember my definition of adult?
Anyone that is like able to comprehend, anyone under 16, basically. I remember you saying.
Prepubescent, post-pubescent, sorry, post-pubescent. Okay, if they're post age of their period or their sex drive, if you're a guy, I guess, then they're an adult, because you could tell them ahead of the test saying, don't bother me. Okay, and they won't, at least they shouldn't. On the other hand, a child, if there's a 2-year-old, they need help and you got to talk to them, if they need something. And I'm not into torturing children. So talk to your child if you have a child. Okay. But if you have, a roommate, tell your roommate ahead of time, don't bother me during those 2.5 hours. Got it? Okay. No materials or devices. So smartphones, put your smartphone in another room. Don't even have it in the room with you. Put it on mute, put it in another room. Don't let it distract you. Got it? Because that would be cheating to use your smartphone. Okay, I know for some of you it's hard to even spend 10 minutes away from your smartphone, but you need to do that. Okay, and no hand calculators. You're allowed to have, the calculator is going to be embedded in the exam. All right, so now in the kind of how many question dish. So let me talk about the questions on the exam now. So number 1, again, you should all get 100% of number 1. I think it's 1 point. Okay, or it's negative 100%, because basically you can't get any points if you don't agree to this. Okay, 2 through 7 are true false questions. Okay, those are true false questions. You've had some true false questions in the homework. Do you remember?
Yeah.
Yeah, so they're true false questions. They're in Canvas and there's no partial credit. But let me ask you a little probability question. If you leave it blank, what is the probability that you are going to get points for it?
0.
Good. If you have no idea whether it's true or false and you guess, what is the probability that you're going to get points? Yeah, 50%. So what is a smarter thing to do?
Guess if you don't know.
Yeah. If you have no idea, do not just leave it blank. That's just dumb. Hopefully you get that. Hopefully you do have an idea and you know why it's true or why it's false and you click on it. Does that make sense? Okay, but don't leave it blank. Don't leave anything blank. So that's true falses. And then numbers 8, 9, and 10 are multiple choice on statistical ideas. Okay, so that's going to be like vocabulary. So where have we had a bunch of vocabulary words under the same topic? For example, yeah, sampling and data. So sampling technique, Okay. Maybe even what statistic is the right statistic. Okay. Or what might the statistic be? Okay. So those are more thinking questions, not calculation questions. Any questions on 8 through 10? Okay, then all the rest of them are individual questions. And I want to let you know that 1 through 10, those are quick questions. They're not worth many points compared to the rest of the problems. Okay, because you're going to be able to do basically 1 through 10 probably at the same amount of time that you do number 11, okay, or number 12. They're quick questions. So they are worth less points. Don't leave them blank, but don't spend all your time on 1 through 10 or it'll kill you because most of the points are in 11 through 18. So let me go through the rest of the problems. Number 11, finding and using statistics. Okay, so if I give you data, you should know how to use a calculator and get statistics. You should understand how to interpret the statistics. You should understand how to deal with the statistics and use the statistics. Any questions on number 11? Okay, I know I'm being a bit vague, but I'm not telling you every word of the test. Okay, number 12 is a probability question. Just to note, what chapters had probability? Yeah, chapter 3, 4, and 5 all had probability. So I'm not telling you which one. Okay, it could be a mix of chapters, but you're going to have to be able to do probability stuff. Okay, number 13. It's going to have a paragraph, which I'm not giving you. Okay, on the exam I will, but not right now. And then there's going to be an A, B, and a C. Part A is write down the probability distribution table for this situation. Part B is calculate the expected value and the standard deviation for this situation. Part C is use a complete sentence to interpret the expected value. We have to write a paragraph, or will there be a paragraph? Oh, no, this right here, this will be a paragraph, the situation. Okay. So this will be a situation, kind of like your homework. You were given a situation and then you had to fill in A, B, and C. Do you remember doing that? Okay, and you had to do it on the quiz also. Yeah, the quiz, I gave you something like that. I'm just not telling you the paragraph because I don't want you to just memorize a problem. I want you to know how to do problems. I just want to note something. Part C, see if you remember. What words must be part of this complete sentence? There are some words I told you must be in there. And when I went over them, I said it will be on the exam. And we're there now, or we'll be there on Thursday. Do you remember the words? Average, good. Very likely. Okay, give me some more. A couple more.
Close to?
Close to, and there's one more.
Many.
Many. Okay. I'm telling you, part C, if you don't have those 4 words, what's going to happen?
You won't get it right.
You won't get it right. Okay. I want to let you know, I'm giving you a note sheet. Don't be silly. You don't even know which problem it is. But don't just write down those 4 words and think you got the whole thing. It needs to be a sentence. Okay. But those words should be in the sentence. Practice with it. Okay. You don't have to memorize it. You can put it in a note card if you want. But that needs to be there. And I don't know what to do to tell you this has to happen. And you don't want to lose points. But I've been teaching for a long time and a lot of people don't put them in. I don't understand it at all. Put them in. Okay, be there. Okay, and it might be because they're not showing up or watching this class, but that's their problem, I guess. Okay, so how should you practice for number 13? Any suggestions? Yeah, you can redo the quiz. Okay, remember that the lectures are all recorded. The webinars are recorded. So you can always go back to that webinar. And what I recommend is going to the webinar, watching the first, 30 seconds of the quiz before I go over the answer, and see if you can get the answer before I go over it.
I have a question.
Mhm.
I don't know if you're supposed to tell us this or not, but is there by any chance like a table for the probability distribution?
Well, let me read part A again.
Oh, I'm sorry. I did not.
Yeah, probability. Write down a probability distribution table.
Okay, that
Oh.
answers. Okay, thank you.
Yeah. What I'm not strict about is formatting. I don't care, you know what I mean? If you have trouble using the table format in Canvas, as long as it looks like a table, that's good enough. Does that make sense? So I'm not picking formatting, but you need to have your X's and your P of X's right. Okay, they need to be labeled. Yeah, you make up your own questions. I'll tell you, when I was a student, that was something I always did. Part of my studying is I tried to make up a whole test with my friend, and we each did it, and then we did each other's test, and we tried it. Sometimes I got lucky and I got exactly the problem the instructor asked. Not usually, but sometimes. So making up your own problems is a good idea, especially by watching the videos, making up your new ones. Okay, so number 14. Question 14, read and describe a chart and understand the associated statistics. By the way, what charts are required? Do I require in my class for you to know? Hint, there's 3 of them. Yeah, box, histogram, stem, and leaf. So get ready for it. It'll be either a box, a histogram, or stem and leaf. Okay. And you should be able to understand that. Okay. And be able to describe the statistics. All right. Then I'm going to get more specific on the probability kind of stuff. Question number 15 comes right from chapter 3. So that's a probability problem. Okay. And I'm just going to tell you, looks like a chapter 3 question. I'm not going to tell you all the details, but you can always practice the homeworks again. Question number 16 is a uniform distribution question. Okay. So that's where you have, what's the key formula for the uniform distribution that you're going to use over and over and over again? Because there'll be parts. Yeah, A equals BH. Area equals base times height. Okay, if you are not using area equals base times height, you're not going to get it right. Okay, and either you'll know the area or you'll know the base. And the height you can get by doing the original and saying the area is 1, the base is the high minus the low, and the height is h, and then solve for h. So h you can get at the beginning. So again, you can always look at the videos, the webinar. I do an example. Won't be that much different. Okay, number 17 is the normal probability question. When was the last time you saw a normal probability question?
Last week.
You saw one more recently? Yeah, today's quiz. Okay, there was normal probability, but it had central limit theorem. But once you actually all day today, once you actually write down the distribution, then it becomes a normal probability question, right? Okay, so today it was like the second half of every problem was a normal probability question, right? The most recent one was the one for sums. If you look at what I did over here, once I had this written down, then it just became a normal probability question. Find the third quartile where the mean is 3,400, standard deviation is 379 point, etc. And the third quartile, find the third quartile, right? That became a normal probability question. So you've seen those today, but not the whole part. That's like the second half of everything we've done today. So hopefully that'll go easy for you. Hopefully you'll know to use the normal probability calculator if it's a normal probability question, because that's what you need to use. Okay, then question 18 is read a chart and find probabilities. Okay. So again, if you don't understand the charts, you have no chance. If you understand the charts, some of them are going to be really easy. Some will be a little bit harder because there's different parts. So that's the test, by the way.
Just 18 questions?
You want more?
No, I'm happy.
Oh,
That was
A lot of people complain that my tests are too long. But remember, these have, they have part A, part B, part C. Like, I specifically wrote on 13, A, B, and C. Do you see that? So
most
most
of
of
the
these
tests
have
I've taken in
parts.
college have like 100 questions, so
No one would ever finish till I get 100. I can guarantee that. Yeah, there's 18. And if I give too few, then you miss one problem and it destroys your whole score. Okay, so hopefully you don't find it too long. I do my best. It's really hard for me to know how long it's going to take you because it doesn't take me long at all.
I have another
Because-
question.
Sure.
Let's say, not saying that we are, but let's say like most of the class like bombs the test. Do you like do curve grading, or is that something you don't do?
There's no guarantee on a curve grading.
Okay.
Okay. But here's a question, extra credit question. I forgot to announce it in my other class, but there is an extra credit question. Okay, and here's what it is. I'll tell you word for word what it is, because it's what I give in every class I ever teach. And it is, write down one suggestion or one thing that is going well in this class and one suggestion for the instructor that will make the class better, basically. That's basically word for word. And if you give me anything to those two questions, then I give you the extra credit. If you leave it blank, I do not give you the extra credit. Okay, so you don't have to like feel like you have to humor me or anything. But the one thing is that if you say that here's something I want to change, then be ready for it to get changed. If I change it, don't get mad at me because you asked. Got it? So be careful what you ask for, because sometimes you get it. So that's the extra credit. Okay, and do the extra credit. Do not leave that one blank. Okay, that's kind of where I curve. If you're wondering about the curving, is I curve by extra credit. And they're called fudge points for the extra credit, basically. So hopefully that answers your question about the extra credit, and that's the last one. So I think it might be called number 19 on the Canvas, but it's really the extra credit. And I think I officially make it 0.01 points because I don't think I can make it 0, but that's basically 0 points. And you can get points, more points than it's worth. That's why extra credit is. I don't remember how many points it is, but what matters is the percent that you get. So it's probably not 100, it's probably not 150, it's probably some weird number. But all that matters is the points that you get, and then the percentage of the grade. That's here. It's 15% of the grade. Yeah, out of 139 just means take your number of points, divide by 139, that's your percent, multiply that percent by 150, and that's your course contribution. Does that make sense? So kind of the math behind the calculation of the grade. So it turns into a percent, and that's just Canvas doing that. And then multiplies it by 15%, and that's the contribution to the course. And that's what matters. So out of 139, that's not an important number. What's important is the percent that you get on the test. Okay, what I am noticing is that we are at 5:51, and I try not to go over.